So at -2 we've got 4. At 0 we've got 0. And at +2 we have 4. This is reflected across the y-axis. You've got, it's an even function because you have symmetry across the y-axis, right? So this is an even, it's important, this is where we start y'all out in understanding like the difference between odd and even functions. Now, if you want to define your 0, which is really the fundamental theorem of algebra, really, then what do? What do we set y equal to?
0.
Right. So let's do the algebra. What do I do on both sides?
Divide by x.
Well, you could do that, or maybe I wouldn't divide by x, right?
Oh, I see. It's taking the square root.
Right.
Is it taking the square root of 0? No, it's not 0, is it?
Plus or minus 0, right?
Yeah.
So what happens? So when you've got multiplicity 2, right, at any root whatsoever, this being the most basic case, you've got 2 zeros, that being 0 itself, right? 0, 0. And when it's multiplicity 2, what happens to the graph is it'll ping, right, and bounce, right? That's important. So when it's even, you bounce. When it's odd, you cross the origin, or cross wherever the root is, sorry, wherever that root is. Technically, what we really have is x minus 0, x minus 0, right? Or x plus 0, x plus 0. It doesn't matter in this case. But that would give you x times x if this was in factored form or root form. If you simplified it down, that's just x times x, y equals x squared. It doesn't always need to just be the function x squared, as we discovered yesterday when we were factoring. Now, if you look at the odd function up here, right, now that we're odd function today, we're understanding odd functions, right? So it's the whole crux of the difference between even and odd functions is the start of the lesson today. And these rules right here will come into play later on. So the idea here is that I'm just teaching you the nature of even and odd functions. But what if we had something, let me get AI to generate a problem for us. It's a little more involved than just x squared or x cubed, right? So, and one of those might be, where did we start that? That was on page 1. If we go here on page 1, Paul's online math notes gives us one. Is that in fact an odd function if it starts at x cubed? Let me go ahead and snip that. Let's see. All right. Okay. Something a little more involved. Now I can use Mathematica if I want here. Where's that at? Let's see. Do I have my other account? Yeah, right here. You okay?
Yeah, just my head hurt real bad. That's what happened.
It's like every day for me, my guy.
Yeah.
Minus 5x. And I'm going to ask AI to do something for us. Go ahead.
I woke up at 5 a.m. this morning, so I am tired.
Ooh. Well, I'll try to keep it simple. Why don't we just continue on with what we were doing yesterday, okay?
No, it's fine. We can do this. I'm perfectly good. I'm just saying fact. We can continue. I'm ready for it.
I just want to make sure that I stay in concrete the way I like to do it because, and I think this is perfect. I think that kind of just going in.
I mean, I think you're doing a real good job because you're changing quadratics from x squared to, cubes. So I think that's a good way to go.
I think so too.
Yeah.
I think that is. Yeah, I would agree. I think so. Thank you for confirming. I think that's the way we need to go. Because what we're going to do in the last video, in the last lecture, we were factoring, and then I got to long division, didn't I? Now,
Yeah.
now, see, this is where the confusion hits people, right? What's going on? We go for factoring and then dividing. How did that happen? It just happens to be that we can hack the process of rational functions to prove that that something's a root. We can find the other root, and if the remainder is 0, then we factored it. So we can do that. It's not that you started with a rational function. You're just making guesses using the rational root theorem. But let's continue back to seeing if something is an odd function. Let's see if AI can give us the algorithm. A lot of times we use the sign, like how many changes you get. I think it's Descartes' rule. This function is odd, or even, or neither, because they'll ask you, is this symmetric? And I'm going to plot it in a minute after we go through it. Okay? Of course, I'm correct here. I'm not sure if it's called Descartes' rule. I think it is. I don't remember the history as much as I know the applied in teaching the math effectively. So let me go. If the function is even, this is why I love AI. It just makes the lecture so much quicker, and I can do what I want to do. And it gets all the nuanced stuff, not nuanced, but the traditional stuff out of the way for us. I want you to notice that when we're doing operator notation, we're just going to use p of x here for our for our polynomial, yeah. So we're going to say, and we're going to go ahead and plug in, AI did it, so I'm just going to post it on there because it's going to be a lot quicker. And that kind of helps y'all see it like from like what a book would, but kind of better because we're actually doing this in real time.
Yeah, I like how AI did it. Because it says that whatever f of x, aka y, will equal positive y, that's x squared, we know that. And a function is odd because f minus x, f of minus x, it will give you the negative.
Right.
So,
and what I'm going to do now.
What do they mean by compute? To solve?
Let's see. No, look. Compute means you're throwing. Now, this is operator notation. I need to discuss what that is. Do you know? Are you been aware of operator notation?
I mean, in my algebra 1 class, we did something similar. I think we did like that, but I don't remember it being called p of x.
Okay, so any function, it doesn't matter what you put here. That's just symbolic. Why do we do that? Well, because when we're defining anything in math, we define it with letters. If this is your polynomial that you start with, then that's going to be equal to this times the root that we're looking for. So we're looking to guess this, right? In order to factor something. So what that effectively means then, if we start with a polynomial p of x, that's a function. Do you know why all I'm saying is that we use p of x to say this is a polynomial. It doesn't matter what you put, f of x, y of x. This is the same rule, right? If it's odd, then f of negative x is equal to negative f of x, right? Likewise, it would be the same thing if you put p. It doesn't matter. Does that make sense? Positive. If it's odd, then you're going to have the negative. That's how we test it. So first we're going to learn how we test that. So let me go ahead and let's see. Let's go ahead and do that here. So when we plug in negative x cubed in here, got a lot of windows left on my master shredder over here. I got 1,000 things. So we simplify this thing. Let's go ahead and do that. We're going to have this. That's going to be a negative x cubed. Positive, you got one, what is this? The same sign, nothing changed there. You got a sign change here, and minus, I didn't need to put that. It's very important to realize that this is not operator notation. Are you aware of that? This is operator notation. Do you know what that means?
Is it the
It tells the user what to plug in for x. So we're plugging in
oh, so
negative
that,
x in for x, and we're
it's
testing
called
it.
operator notation, right?
Right. And,
Operator notation, operator notation, operator notation, operator notation.
right.
Finally,
It tells you
go,
what to
go.
plug in. What that means is, let's do it. Let me show you over here. If I said x was equal to -1, I would tell you, they may do a table, or they just might ask you, they would show you this, right? And you would
Mm-hmm.
plug that in. -1 cubed. Notice the use of parentheses. That's 2 times -1 squared, minus 5 times -1, minus 6. That would simplify to -1 plus 2, and then you'd have plus 5, and then minus 6,
Mm-hmm.
which simplifies down to 1 plus, that's 6 minus 6 is equal to 0, right? You understand what it means? So let's do p of -2. That tells you to plug in -2 for x over here.
Well, negative, yeah, 2%. Yeah.
That's
Oh,
what that's operator notation, okay?
so basically, so the operator is just basically whatever x is, right?
Yeah, it tells us what to plug in. We got to do another.
Are you kidding me right now?
I know, I hate it when it does that. I really do. Hold on a minute. Jeez Louise.
This is a lot. Why do I find this easier than quadratics?
Well, because we're just learning some basics here, probably. That's
That
really
makes
kind
sense.
of, yeah, that would be why there. So what I'm going to do here, give me a second. I got to, okay. We're going to do operator notation. Let's see, testing symmetry. I think it's Descartes' rule. I'm just going to keep it simple. Testing symmetry in zeros and the fundamental theorem. Okay. All right. So let me get this for you. Let's see. Golly. Getting really. Hold on a minute. Okay, let me put this on the next slide. Let's see here. Okay, got it. So do you hit that link there and let me know as you get on there.
I am here.
Jeez. Alright, there you are. Good deal.
Oh, no reverse. No reverse, I'm not here actually, because it hasn't downloaded yet. So technically, I'm not here.
Give me a second. Okay, Agent Smith. Agent Smith's noodles. Alright, let's...
Okay, Adam's not sure I'm here.
Let's see. Who are you to think that you... Let's see. There we go. I'm gonna put our work here on the new one. Hit that timeout, like that, the thin strokes, please. Okay. New page. Sorry guys, I had to... Technical jitters. Alright. We are going to do a lot of interesting things today, because the way I crash course this is I really get the more difficult things out of the way, as we discussed before, that kind of... We use polynomials when we do series and calculus to approximate the other functions. So it's a great starting point. Right, so that's why we do this. And I like to get all the important things like out of the way here. Oops. And then, good grief. Get all this out of here. Yeah. Jeez, man. All right. There we go. Thanks, guys, for your patience. Let's see, but I need to, what's going on with that? It's like the wrong page. Give me a second. There we go. That's more like it. Alright, now we're on. Okay, so what were we getting at here? We were getting at, where's my mascot? Where's Rocket at? She took off. So, here's the thing. We were on operator notation. So you plug in this and you get something out of it, right? So what they're doing when they test this, all right there, what's that guy's name from Phone Wars? Salahuddin, Salahuddin, Salahuddin's your nickname. Awesome legendary figure. So this is going to be what we just did, right? You plug in negative x into the function, the original function, into the operator, or the teacher will ask you, or the book will ask you. You plug that value in. We're testing to see if it's symmetrical or not. If it's symmetrical across the y-axis, it's even. This is an algebraic technique, and I'll show the graph too, but if it's across the line y equals x, then it's got odd symmetry. So that's the whole purpose of this. Now our original function, to go back at what we were doing, when y'all learn calculus, it's going to be like, this does help, but it's a little more convenient. So you've got x cubed for your original, and we're going to compare the signs of each coefficient. So you've got x cubed, 2x squared, the original one, negative 5x, and minus 6. We have a sign change here. I think that's what we're getting at, right? Mm-hmm. And it looks like we've got a sign change here. Mm-hmm. So then now we compare them, which we are doing. They're not equal, so the function's not even. So if these don't give you the same function back, and that's the rule up here, it's not even. Of course it's odd, but the thing about this is it odd though, or is it neither? That's the big one. We never address the fact, is it even, odd, or neither, because they can be neither. So looking at it, it's not equal. And the other situation is, now we check to see if it's odd.
Well, it's going to be negative 2 times negative 2 is 4 times negative 2 is 8. Oh wait, no, you didn't plug in anything correct. Never mind, what am I solving?
Right, so since the polynomial is both odd powers and terms and even powers, it's always, almost. Right. Usually, almost always, going to be neither when you have so many terms, odd and even. But you still have to test it. So I guess the idea here is, and I don't use Descartes' rule that often. And today we were going to do like, here's the rule, guys. Good grief, man. So I want us to notice that when in our original function, that you had a sign change in the odd. You had 1, but this one in the middle did not change. So since they all didn't change, this is neither even nor odd. If you had all cubics here, that might be the scenario. And then you've got, for the even function, when we did that test, they did not stay the same. The negative x cubed, of course, switched to negative x cubed from positive x cubed. So you have neither even or odd here. Now,
Ninja vanish!